one side of that handout
What's your last
talks
name?
about a function. I'd like to have a student to volunteer to read the definition of a function. I'll show you some examples. Based on my examples, I'll ask you, do these look like functions? First, I need the definition, so I know about the definition. What was that three for me? Definition for a function.
John?
There we go. Go for it.
What's your last name?
Okay, so it's going from x to a y for a function.
Thank you so much.
Now,
What's your last name?
read that to me one more time.
A function from a set x into a set y is a relation that associates with each element of x exactly one element of y.
That's my definition at Stanford.
Thank you.
Definition doesn't change.
Hi, what's your last name? Martin.
And I told you about my student who took his, he's in calculus now in California, happy for math 2, and he left us. He was off from university early, and now he's at Columbia. He just took his first calculus. I think I told you guys the story. Got 72 out of 80 on his final exam. I was very proud of him, and he had this course before he went off to Columbia. Now, all of a sudden you see that definition at Columbia, MIT, wherever. It's the same definition. No matter what school you go to. She says, be careful, professor. Seems like I hear an X and a Y. Can anyone tell me associated with function before I jump into some examples here? What on earth do you think the X and the Y, based on your experience, might be given names if I'm discussing a function? If you just reflect back to your last math course, whenever that was, and all of a sudden you see there's an association here, they're telling me, between X and Y. Anyone recall, what did they call that X? They had a particular name for it. And they gave a particular name for the Y, for a function. Do you want to recall what it was? And I don't think she's read to me the words I'm looking for. I think, any idea? What is the X and what's the Y they're talking about? Here we go. And this will make more sense because I know you've seen this before, you just have forgotten. The X is known as the domain. The Y is associated with range. So we have a domain, we have a range, we have a function. An X and a Y, domain and a range. Now, with what she read to me, I will jot down an example. Let me start out with, I'm going to write these guys as an ordered pair, because if I'm using an X and a Y, you know surely, Professor, chapter 1's taking me into ordered pairs. An X and a Y, and pretty soon that chapter is when I should plot these points and graph them. Right now, though, I have an X and a Y ordered pair. Suppose I ask, I'm going to give you a set. Let's have in this set these numbers. Let me throw in one more. Guys, this is an X, this is a Y, for all those ordered pairs. I made that real quickly. And if I have no mistake, can I classify that as an example of her definition of a function? Based on what she read. Okay, let me ask her to read that statement to me one more time. Who's reading?
A function from a set x into a set y is a relation that associates with each element of x exactly one element of y.
There you go. Each element of X must be paired up with only one element of Y. Please tell me, I got -1 paired up with 4. Do I have -1 paired up with anything else? No. I have 0 paired up with 5. Did I, for some reason, pair 0 with something else? And down here, 1 is paired up with 6 and only 6. 2 is paired up with 7, only 7. I met that definition. So this would represent a function. A set of ordered pairs satisfies her definition. Now, if it is a function, you know the notation. You've had math before you got to my class. The notation is, if it is a function, you get to use notation like f of x, g of x, whatever you want to call it, h of x. You get to use a symbol to show this is a function. I'm going to use f of x. Now, can anyone tell me, what did I have in mind? Because I stood here and did it quickly. There's an association between those numbers. Here to here, this to this, this to this, this to this. What did I have in mind for an association between those numbers in each one of those ordered pairs? Does someone see a relationship? If so, I'll write it like an equation. And we'll have the name of the function. What did I have? I didn't just throw these at random. -1's paired up with 4. I paired 0 up with 5. 1's paired up with 6. 2's paired up with 7. I had something in mind. We're going to go through these now. Thank you. Thank you. Does anyone see a pattern there? I see a hand going up. Yes.
X plus 5.
X plus 5. You're taking the x and adding 5 to it to get the y. So if I take, as he says, professor, -1, you add 5 to it, you get 4. 0, add 5 to it, you get 5. It's consistent all the way down. It's got to be consistent. Take 1, add 5, you get 6. 2, add 5, you get 7. So he says, professor, just in general here, write this as the function says you take x plus 5, and that's the name of the function. You're adding 5 to the x. Now, that one works out nicely. Now, the domain on this function, when it is a function, I'll be asking for the domain. Well, the domain should be the set of x's. Let me put it right here, guys. I'm looking for only the x values in those ordered pairs, and they call that set domain of the function. Guys, my x is here in the blue, and I'll put it in a set like this. X is -1. I see x in the next one, 0. X in the next one's 1, and then a 2, and there's my domain. The set of x's. Range, I'm going to use R here for range. Now you're looking for the set of y's. So go through my blue, pull out the y coordinates, place them in a set. I see a 4, I see a 5, I see a 6, I see a 7, close that up, there's my range. So I've got a domain, I've got a range, and we named the function, and it is a function, and works out beautifully. No problem. No problem. Much easier than solving an inequality, I guarantee you. Part B, I want now, let's see, what do we want here after this, or not? Function, yes, let me give you one more example. Watch carefully. Let me try to create one here, you guys. I want to show you. Oh, here we go. Just mixing all these up. It looks like that. I made that quicker. The x and the y, I know where the x is, I know where the y is, so do you. Now, based on our definition for a function, may I classify this as a function or not? Okay, let's look at it carefully. -3 is paired up with 9. Do I have -3 paired up with something else? No, it's all just paired up with only 1. -1 is paired up with 1. Is -1 paired up with anything else? No. 0 is paired up with 0, 0 is not paired up. I know what 3 is. Down here I have 3 paired up with 9. It just so happens I also have -3 paired up with 9. But is 3 paired up with anything else besides 9? So did I have each one of those paired up like they should be paired up? So can I call this a function? Based on her definition. Now, I need some help. Can someone tell me what did I have in mind? In each one of those four ordered pairs, there's a relationship between the x and the y. What is it?
X squared.
There you go. You're squaring the x to get the y. Consistently on each one of those ordered pairs. Done. Last one here for an example. Let's classify this as a function or not a function. Oh, by the way, before I leave it, I guess I'll leave it. My domain on this, based on what domain is, the set of x's. Yes, it's -3, with -1, 0, 3. Range, I'll use the letter there. Set of y's, yeah, we got 9, 1, 0, of course the 9 repeats. Those things out. I got 9, 1, 0. -3, -1, 0, 3 for the domain. So there's domain, range, and there's its name, we're done. Now the next one, letter C. Can I classify this one as a function? Here goes. Close it up. Based on her definition, is this one showing, illustrating a function? Now let's see what the issue here is on this one. I have 9 paired up with -3. Do I have 9 paired up with a different number on down there? Did I have 9 also paired up with +3? That cannot happen if it's a function. So this one is not a function. I will not ask for a domain or a range. It's just not a function. Now, I did have though in mind when I wrote the numbers down, I did have a pattern here. There's a pattern here. Can anyone see what the pattern here is, even though it's not a function? Can anyone come up with a relationship? You guys have done a good job on these relationships. X squared on this one. Over here, you gave me x plus 5 on this one. Is there a relationship here?
Square root.
Ooh. Ooh. I heard of square root.
X.
If I take square root 9, what is the square root of 9? It's supposed to be equal to, guys. 3. If I see the square root symbol, it's always, they're asking for the positive square root. Don't say square root 9 ever is a plus or minus 3. After you leave us and go off to some university, you say that and don't tell them that you had Francie. Don't mention my name. Square root 9 is just 3, not plus or minus. Okay, something else I had in mind, not a square root. What did I have in mind as I wrote those numbers? There's a relationship among those numbers. The x is related here to the y. The x is related to the y. X is related. There's a relationship going on. What is it? And though when you give it to me, it's going to look strange, and it's not a function though. I thought someone I heard over here had a very close to it. Anyone see it? Looks a little strange. Here it goes. The best I can say is, I was thinking about this. The x is equal to the y squared. Is the x coordinate, each one of those ordered pairs, and then you look at the y squared, are they equivalent? So the x is equal to y squared, though it's not a function. We're not going to list the domain or range. So basically, guys, that's what a function is. You read the definition. There's some examples there. I'll have just enough time here to show you. You have the handout. On the side here, part 2. And I'll finish up with this. I'll tell you more about that quiz. Please tell me, on the handout on the side where you have functions, did I name a function for you? I think I did. I actually wrote what, f of x equals something? Someone check and see if I did. Was there an f of x equal to, and I gave you a name for it, or what? I'm trying to remember how I did it. Oh, I did. If I'm looking at the right one, guys, it says f of x equals -2x squared plus x minus 1. I think that's the one. On your handout. -2x squared plus x minus 1. Does everyone have that? Now, you're talking about easy to close down since you worked so hard tonight? Did I now have a string of things to answer about that function? What was my first question? What was the first item here about this function? More than likely, I should find f of what number?
Zero.
Zero. Please tell me. This is not an inequality. This is not sign analysis. This is not solving an equation with a radical in it, square root. This is simple. What do you think f of zero means for me to do to find the answer? You're going to go back to the given, thinking it's a gave to me, and replace all the x's by zero. That's exactly where that value will be given to you guys. That's x. If I replace all those x's by zero and I'm patient, I will end up with, and I'll do it quickly, -1. That's what arithmetic. We're done. I'm not going to ask you to do this. You're finished. But what it really means is, as an ordered pair, I gave you the x via 0, and you crunched it out, the y is -1. That's what it says. I just want -1 though. Someone remind me f of what next? -4. You guys should be patient. Put that -4 in there for x. That's why I love function values here. Very, very easy. And then -1. Now watch me miss it. Okay, square first, of course, by order of operations, get 16. Times a -2 gives me a -32. -4, of course, -1. I think altogether it's a -37. You're finished. You're finished. That's the function value. Okay, next. Someone tell me what the next one was. F of what? After a -4, what was it? F of what? 3 halves? 3 halves. Be patient. Put the 3 halves in there for the x. Can't go wrong in these. I know this is a fraction, so you gotta be a little careful. I give you partial credit just to show me you put that in there correctly. Now crunch it out. Be careful. It's a -2 times, I gotta square that first. That's 9/4. And then of course I got this, I got that. I'm just doing arithmetic now. I could cancel 2 into 4 to help myself out, make that a 2. Guys, let's call it the first fraction -9/2. I just cleaned up a little bit. I canceled 2 into 4. Then of course I got plus 3 halves. I got -1. Is that true? We didn't make a mistake, did we? I'm right on top of the board doing all that. Is that arithmetic done correctly? Let's hope so. Now, if I put these two together, this is across the street type problems. It's a middle school. -9 halves plus 3 halves. Is that -6 halves? Or a better name for -6 halves is what? -3? Are you kidding? And -1? If there's no mistake, there's the answer. Did anyone get -4? Did anyone follow the way I crunched this thing out? Is it -4? I did it quickly. Okay, just plug that up in. Be careful with the math, the arithmetic, and you got it. Number 4, since I don't have the handout right in front of me, someone was telling me what they were. What's the next one? Square. Oh, beautiful. F of radical 2. Same process. Let's go back. Careful, put in radical 2. And you get this. A little strange, but you do it. Now, can I clean this up somewhat? Even though it's looking strange. Guys, right here. Radical 2 squared. What do you think radical 2, when you square it, is going to give you? What's the answer for just a radical 2 and you square it? Radical 2 times radical 2 is radical 4, or a better name for that is just merely what? 2. So out front you have this going on. And of course you still have those terms going on. Radical 2 squared is 2. This is a -4. radical 2 minus 1, collect my numbers, -4 and a -1 is a -5, plus radical 2. That's all I can do. I put my numbers together, can't do anything with that square root. Leave the answer like that, you're done. Okay, in about 5 minutes, 10 minutes, we're gonna be done. Please tell me, at this moment, is this easier than inequalities? Is this easier than solving a quadratic by quadratic formula? Of course it is. Will any of this be on the quiz Wednesday? No. Will a lot of this be on the exam next Wednesday? Yes. Okay, I need one more here. Number 5. Someone help me out. Have a what here? What was it? X minus 5. Gotcha. Same process, just be careful. -2 times x minus 5 squared plus x minus 5 minus 1. Step back and make sure I put all that in there right. Looks like all the x's by x minus 5. Now I give you a little half a point partial credit there. Just show me that. Now I gotta finish it up. Does anyone know right offhand, be careful, what is x minus 5 quantity squared? What give you? Now I'll tell you this, it will not give you x squared plus 25. It gives you more. So it's not x squared plus 25, you square it. Can anyone say what it is if you do square it? Go for it.
X squared minus 10x plus 25.
Love it. X squared, subtract 10x plus 25. That's x subtract 5 and x subtract 5, thank you so much. And of course, still got the -2 going on here, and I'll come back to it. Still got this. And you got that. Now, can I clean up further? You gotta use the distribute property, distribute the -2. You're going to end up with a -2x squared. Please do not let me make a mistake. Plus 20x minus 50. Strange numbers. Still got this. Got this. Gotta check, see if that looks good. I think it looks good. Collect like terms. I got -2x squared. Mark that out, that's done. If I put my x's together, I got this plus this for the x's. That's 21x. Strange answer. And my numbers, I got a -50, a -5, and a -1 to put together. What is that? Is that -56? Now, I did that quickly, guys. Let's hope. Is someone following? Is that the answer coming out? Did you combine like terms? That's it. Now, how many more of those do we have left?
2.
2 more? Does the last one say f of x plus h? Tell me what the next one is, though. Before the f of x plus h, what's the next one?
-4x.
-4x. It's a gift. A gift. Go back, let's put that in, be careful. 4x, square it. Plus, in place of x, you're putting -4x. Subtract 1. Guys, be careful. When you square the -4x, that much right there is 16x squared. Times -2 out front. -32x squared. Down here, -4x, can't say anything about it, -1. We step back and look at it. That's it. Isn't it? We lucked out on this one. That's it. That's all I'm doing with it. That's it. Now, we got a good class tonight. You guys will tell me the last one's what? F of what?
X plus h.
You walk into a calc class right now. I'm sure somewhere in one of these rooms, someone's teaching calculus here at SMC right now for one of the evening classes. You walk in, I bet, Anna, Bart, I bet in the calc class, right now, they're probably doing something for the first week or whatever, something maybe with an f of x plus h in their calc classes. Now, I'm not going to show you exactly what that means. I'm just asking, can you set that for me in this problem before we close down? So they're asking for this. Number 7 is called, I guess. F of x plus h, guys, here goes. Same process, negative 2 times x plus h squared plus x plus h minus 1. Looks crazy, you know what, but that's what I'm supposed to do. I went back and replaced x plus h on all those. Now I got it cleaned up. They will be finished for the night. Anyone tell me, and please be careful. I've been bragging on you guys already. Some of my colleagues are really upset with their classes. Oh, they are upset. Let me tell you what x plus h squared is. So I can walk out of here, go back to my office, see my colleague, and ask them, do your students know what x plus h squared is? So I want to hear someone in this class tell me, what is x plus h times x plus h going to give me? Here we go. Go for it.
X squared
Hang on, x squared I will take.
plus 2xh
Rule 11,
plus h squared.
mathematician. That's exactly what it is. X plus h times x plus h. Now, she's telling me, Professor, don't forget, there's a negative 2 out front to deal with a little bit later. But she gave me the hard part. Down here, of course, is repeat, x plus h. And here, minus 1. Guys, this is distributive property. She's done the big part for us. So this is negative 2x squared minus 4xh minus 2h squared. Distributed to the negative 2. I still have this to worry about. And minus 1. Oh my goodness. We did as she suggested. Strange looking answer. As you examine those 1, 2, 3, 4, 5, 6, I got 6 terms in me. Are any of those terms alike? No, guess what? That's the answer. I can't combine anything. That's my answer for f of x plus h. That's the best I can make it look. And that's done. And that's that one big chunk of that handout, I think, done. And you guys have done a beautiful job, but that's chapter 1 started. Now, before you leave, I know you wiped out.